All right, so this week we are going to focus on adding and subtracting mixed numbers with unlike denominators. And in this first example, we are working with 8.5 plus 4 and 5/8. And the first thing I notice is that they are both mixed numbers and they have different denominators. So I've got halves and eighths. And so in order to continue working this problem out, I need to think about what my common denominator is going to be. And your common denominator is another name for the common multiple. So since 8 is a multiple of 2, 2 times 4 is 8, then I know that 8 is going to be my common denominator or common multiple. So I am going to take my 8.5 and I am going to take the fractional part and I'm going to convert that into an equivalent fraction using 8 as my denominator. So 1/2 is equivalent to 4/8. If I wrote that out here, there's a couple different ways that you can think about this. So I can say we are looking for the numerator in the second fraction. So I can say 2 times 4 is 8. So how did I go from 2 to 8? Well, 2 times 4 is 8. So 1 times 4 would be 4. Okay, so that's one way of thinking it. Or another strategy that you can use is called cross multiplying and dividing. And so what that means is I can take 1 and 8 and multiply them together, which would give me 8. And then I would divide by 2, and that would give me 4. Okay, so again, I'm cross multiplying those numbers that are catty corner from each other and dividing by the number that is left, which is 2. And that's going to give me that missing number on my numerator. All right, so those are two different strategies that you could use to find your equivalent fractions. So let me get rid of this. So now that we have the same denominators, we can now go ahead and continue with our problem. So we have now 8 and 4/8 plus 4 and 5/8. So I'm first going to add my fractional parts. So I know that 4/8 plus 5/8 is 9/8, and 8 plus 4 is 12. However, this guy right here is an improper fraction. So we need to convert that improper fraction into a mixed number. So if I have 9/8, I know that 8/8 makes a whole. So I can use 8/8 from that amount to make one whole, and I would have 1/8 left over. So 9/8 as a mixed number is going to be 1 and 1/8. Okay, so that turns into 1 and 1/8. And so now I'm just going to add that to the 12 whole, and my answer is 13 and 1/8. Okay. So you're going to be working with some problems like that later on this week on a performance task. So you can come back to this video at any time to watch this example again. All right, moving on to another example. This is a subtraction problem, and this one has a whole number, and we are taking away a mixed number from that. So this is 8 minus 2 and 3/5. So what we have here is we cannot take away 3/5 if I don't have any fifths to take away from. And so I need more fifths in that spot. I need to get some fifths from somewhere. And I can spell that out. So I need fifths. And where am I going to get those fifths? Well, I can take a whole from 8. I can trade is what I'm going to do. I'm going to take one whole and replace it with a whole in the form of a fraction. And since my denominator down here is 5, we are going to use 5/5 to replace that whole that we took from the 8. So basically, instead of saying I have 8 whole, I have 7 5/5, which in fact is still 8. So now I can go ahead and subtract the fractional part. So I've got 5/5 minus 3/5. That is going to give me 2/5. And 7 minus 2 is 5. Okay. I'm going to slide this over a little bit. And there is another example that is kind of similar to this that involves regrouping, but there's another strategy that you can do, which I talked about last week in a couple of the videos that I posted onto the Google Classroom stream. So if you still feel like you need some practice or some explanation on mixed numbers and improper fractions, I highly suggest you go back to the Google Classroom stream and look at those videos that I posted the first week of February. So anyways, we've got 6 1/2 minus 3 7/8. So first thing I notice, I've got two mixed numbers. I am subtracting and I have unlike denominators. So I am going to come up with the common denominator. And in this case, 8 is going to be my common denominator. It is a multiple of 2. So 6 1/2 is going to turn into 6 and, let me get my pen here, 6 4/8. So 1/2 is equivalent to 4/8. And so now I've got 4/8 minus 7/8, but I cannot do that. I don't have enough 8s up here to do that. So where can I get more 8s? Well, I can borrow them. I'm not really borrowing, I'm trading. I'm taking one whole and trading it in for 8/8, which I need to add to the 4/8 that I already had to begin with. So 4/8 plus 8/8 is 12/8, and that's what I am now going to be working with. So 12/8 minus 7/8 is 5/8, and 5 minus 3 is 2. Now, there's a different way that you could approach this problem, and I will show you that on the next slide. So we had 6 1/2 minus 3 7/8. So 6 1/2 minus 3 7/8. Was that correct? Yes. All right, so I'm going to go ahead and find my common denominator just like I did, and this is going to be 4/8. So now I'm going to use 6 4/8 instead of 6 1/2. The other strategy that you can use instead of the regrouping strategy is you can take your mixed number and convert it into an improper fraction. So 8 times 6 is 48 plus 4 would be 52. That would give me 52/8 up here at the top. And then down here, 8 times 3 is 24, plus 7 is 31. And, 31/8. And when I subtract that, I end up with 21/8, which I then have to convert back into a mixed number. So I know that if I have 21/8, I can make 2 whole out of that. That 2 whole would give me 16/8. So I would be using up 16/8 out of the 21 to make up that 2 whole, which would leave me with 5/8. Whoopsies. 5/8 left over. And this answer is the same answer that we got back here. All right, so that is it for today's video. I tried to keep it to a 10-minute minimum. So if you still have questions on this topic, just reach out to me. You can send me an email and I will do my best to get back with you to figure out where we can work things out.